In 2005, a school population was 1,001. By 2009, the population had grown to 1,697. Assume the population is changing linearly. What was the average population growth from 2005 to 2009? All right, so for part A, to find that average population growth, let's find the change in population and divide that by the change in time. So over those years, the population increased, right? So we would take 1,697, subtract 1,001, divide that by 2009, divided by 2005. So those calculations give us 696 divided by 4, which is 174. So the school population grew by 174 students per year from 2005 to 2009. I should say it grew by an average of. So we don't know necessarily that the population grew exactly 174 students each year. We just know on average it grew by 174 students per year. Find an equation for the population P of the school T years after 2000. All right, so T years after 2000. So it's asking us here to sort of adjust the T, shift the T, so that we're not going to think of T as the actual year, but a number of years after 2000. So if T is the number of years after 2000, and P is the population, it's a good idea to maybe write the ordered pairs. So then our first ordered pair, in 2005, a school population was 1,001. So that means that T would be 5 and P would be 1,001. Similarly, in 2009, so if T equals 9, the population is 1,697. Notice that this, even though we've shifted the data points, the slope will remain the same. The change in population is still 696. The change in time, 9 subtract 5, is still 4. So the slope M is still 174. So then writing an equation, I could then say, well, P minus 1001 is equal to 174 by T minus 5, writing a point slope form. I'll go ahead and take this to slope intercept form. So P minus 1001 is equal to 174 T. 174 times 5 is 870 minus 870. And let me go ahead and add on the 1001. And so then that tells us the population is given by 174T, 1001 minus 870. Is 131, so plus 131. So there is the population in terms of T, where T is the number of years since or after 2000. And so now to predict the population in the school in 2012, we'll take our linear model here and we will simply let t equal 12, since 2012 is 12 years after 2000. And so then the population would be 174 by 12 plus 131. 174 times 12 plus 131. I calculate that as 2,219. And so then our model, the model predicts that the school population will be 2,219 students in the year 2012.